It looks like a 16 megapixel image, but it's actually not. You're actually losing resolution because of that. Basically, you're binning at 4:4. That's why if you take a hydrogen alpha filter and put it in front of like your one-shot color DSLR camera, people will say you see significantly lost resolution, and the reason for that is that you're putting something in there that only allows in a wavelength that can go through the red filters of your camera. Your green filters, your blue filters, they're useless. Those pixels are out of commission. You've got 1 pixel in 4 that are now able to see any light when you put that filter in front of your camera. So what you're going to get is a significantly reduced signal, reduced apparent sensitivity of your camera. The resolution will look the same. The camera will still work its magic and try and merge all the pixels together. But you see significantly reduced sensitivity, and you'll see significantly reduced real resolution when you're actually sitting there and looking at the, after it does its magic. It looks like it's good, but it's not. You see loss of resolution. So, decision to make. One-shot color, I still recommend it. Most people want pretty color pictures. And if you're doing pretty color pictures, it's just so much easier with a one-shot color that I really do recommend them. Anti-blooming gate or not, you're not going to see this option on DSLR. We're now into the CCD camera. Every pixel, you have to think about it in a CCD camera or even a CMOS, you have to think about it as a bucket. And when the light comes in, it's filling up your bucket. Buckets can be overfilled. And they commonly do if you have a bright star or some object. And what happens in a CCD camera is if the bucket gets overfilled, it overflows. And it will overflow into the pixels, into the column that it's existing in, into the pixels in its column. So have you ever seen an image and it's got those lines in it? You'll see a big bright star and it's got like a little line creeping down from it. That's the charge overflowing from the 1 pixel and trickling its way down the column. Okay, it's a pretty significant problem. If that happens in the middle of a detailed area of your image, sorry, your data's gone. You'll never get it back. The way that that's fixed is what's called by putting an anti-blooming gate on the pixel. Every little pixel actually has a little pump on it. It's a little gate, and it can bleed off excess charge out of a column. So it'll take the charge out of a particular pixel and pump it out to a different place on the chip. I don't know the details, so don't ask. But it's magical, and it works. And it will keep, at a certain level, it can keep the system from blooming. So it'll pump electrons out. Now here's the problem. What did I say? We've laid something on top of our chip. That's the problem. There's something on top of our chip. Anti-blooming gate cameras have 30% less sensitivity on average than a non-anti-blooming gate chip. And the reason is you've got this big gate sitting on top of your pixel. And it's sitting there monitoring the charge and bleeding it off. In order to be there to do that, you have to have something physically there that can move those electrons off each pixel. And that thing blocks light, unfortunately.
You also lose a little linearity.
I'm sorry?
You lose a little linearity.
I guess you do. Never thought about it, but sure, I guess you do.
No longer... You get a reciprocity failure a little bit at the high end.
That's true.
Because it acts differently.
I never thought about that. But you're right. Yeah, you would, because you're going to lose a little bit of the sliver on the side of each pixel. So your pixels aren't going to be quite...
because it starts bleeding off, the bleeding off is not linear.
Oh, right. Absolutely right. Well, and the reason, and that's why I talked to, like, Jim Janis is one of my good friends, and I had him review this, and he goes, ABGs are for taking pretty pictures. He's right. Yeah, you don't do scientific analysis with an ABG camera, particularly on bright stars. You want to use a non-ABG camera for that. So anyway, I definitely recommend an ABG's camera if you want to do astrophotography. It's just a whole lot easier. Go and shoot the Pleiades with an NABG camera and get back to me. You'll understand why. Desired pixel scale. Do you want to do a lot of high resolution? You need small pixels. Wide field imaging. This is where you can talk about CCD calc. I recommend you get the largest chip you can afford and the one with the highest quantum efficiency. That's on the right-hand side. What's QE? What's cooling? QE is basically for every for every photon that hits your pixel, what percentage of those photons actually trigger an electron to be generated that can be read by the camera. Most DSLR cameras, I don't know the specifics, but my guess is they're probably in the 20% quantum efficiency range. Like my STL 11000 is in the 50% quantum efficiency range. And by the way, there's a curve associated with periodic error. Wow. Zip. Rewire my brain for a minute. Curve, periodic error correction. No. We're talking about something different, brain. So there's a curve associated with the quantum efficiency. So you'll see that some chips are better in particular bands, in particular wavelengths of light. A lot of people like Jeff Herman, who's got his Alta 16U, isn't that what he got? Which is incredibly efficient, like 60–65% efficient in the H alpha range. You want to do H-alpha imaging, like that is the chip to get. If you want to shoot galaxies, for example, at long focal length, and that's what you're really excited about, think about like an ST10. Its peak quantum efficiency is in the blue range of the spectrum, which is very valuable when you're shooting galaxies and things like that. So there's QE curves that are associated with every chip, and it will show you how sensitive the chip is at what wavelength of light. What wavelength do you want to image at? For most of us, it's just RGB. So just look at the RGB range, in which includes, what is it, like 300 to 800? Somebody work with me. I think that's about right. I think that's about the range of nanometers of light. So nobody's gonna. I don't know. But look at that range for sure. Hot climate. You need cooling. -15, -20. Good targets. The cooler your chip is, the better off it's going to be. You're going to see a lot less noise on your chip, which is a good thing. We've covered it. Software and hardware. This is quick, and then we're going to be right into processing, which is I know where we want to be. Some software packages. I was losing steam in my slide development at this point for the day, so a lot of words, sorry. Image acquisition, camera control, Maxim DL and CCD soft are the two biggest ones for dedicated CCD cameras. DSLR focus, and there's a lot of proprietary packages out there. Images Plus is another one that people do camera control a lot with, and like your LPI is going to come with a package from your DSIs are going to come with a package from me, the AutoStar suite. It's going to let you control those cameras. Image processing, again, CCD Soft and Maxim DL are great. Adobe Photoshop, bar none, hands down, the most powerful software for processing images that's available. If you're really into astrophotography, you must have a copy of Adobe Photoshop. Registar, image alignment and stacking, the best, period. 99 bucks. I'm not here to sell products, but it's really amazing piece of software. Sigma is a free tool, and I recommend everybody use it for your stacking, although Images Plus can do the same thing. It does a really good job with DSLR images. I used it for years. CCD Inspector and Noise Ninja CCD Stack, also great tools for a variety of purposes. Planetarium software. I put Starry Night on here, but I don't really recommend it. The reason being is that none of the, in fact, I'm not aware of any automation package that supports Starry Night. One of the neat things about a lot of these software packages for astronomy is they support extensive scripting interfaces, which means you can write programs that will interface with your telescope if it's controlled by the sky, or if it's controlled by an ASCOM driver. You may hear that term. It's a standard drivers that you can use to control telescopes. You can control CCD Soft, you can control Maxim. That's what lets software products like CCD Commander, CCD Autopilot, ACP Observatory Control Software control your entire setup and do things in a very automated fashion for you. Starry Night does not have a scripting interface, which means none of these packages support it. So I wouldn't spend your money on it. I'd put it up here though, as some people do use it and they like it. Some other things to think about. PoleLine Max. I have a love-hate relationship with PoleLine Max. It helps you if you have a CCD camera polar align your telescope very accurately. It also just occasionally fails and throws out results that are totally inconsistent for no apparent reason other than sunspot activity or it's angry with me for the day.
Well, that's not my imagination.
No. It's sometimes you're just like, wow, 60 arc minutes? No, I'm pretty close. I know I'm pretty close, and that's wrong. And before you knew that you were wrong, you're like cranking and adjusting and what the hell's going on? Now I'm the other way, 60 arc minutes. It's really bad. When it's on, it's really on though. Focus Max, awesome free autofocus software if you have something like a RoboFocus installed. TCC from RC Optical Systems, a lot of the specialized hardware for controlling focusers. Pinpoint, it can do very high quality plate solves. So you take an image, take a photo of the stars, tell Pinpoint roughly where you're pointed, drop in your image, and it will tell you exactly where you're pointed by matching up the stars. By the way, the sky, if you have the Serious Astronomer Edition, although if you want to do automation, you have to go pro. You have to go pro because they disabled their scripting interface. Way to go, Bisque Brothers. They disable their scripting interface below the pro, so you have to have that version. Anyway, you can image link there as well, which is a similar plate solve feature. Pinpoint is 1,000 times better and more powerful though. So what I put together here are just some general setups that you could use to think about, what an introductory setup might look like, intermediate setup, and advanced setup. This is heavily influenced by what I did.